Okay, everyone, I think we're going to go ahead and get started. We have a lighter crowd today, but this is Tulsa Lambda Lunch, and so we'll be talking about flow types today, and I'm presenting. My name is Greg Tatum. I work for Mozilla on developer tools, specifically performance tooling. So I write a lot of JavaScript and use front-end technologies for that. I also help organize Tulsa Lambda Lunch whenever Darren does most of the work, and occasionally I help out. And today I'm the backup speaker. So, and thanks to Tech Systems for providing the food. We always really appreciate it. And there's Tara and Sarah over there if you want to go chat with them. Say hi. And Tulsa Lambda Lunch is part of Techlahoma, and of course you can always donate to Techlahoma on the website and help support them. And thanks to 36 Degrees North for giving us the space. And I think that's all the kind of announcements. Oh, other than if you want to give a talk, come find me or Darren, or post in the Slack channel about it. So with those introductions kind of aside, let's go ahead and dive into Flow. So JavaScript is a dynamic runtime language, and it doesn't really have a type system associated with it. It has some very kind of weak and loose kind of typing that goes on with it, but nothing robust that you'd see in other languages that you might rely upon. So Flow gives you those types, and it's a system that's created by Facebook. So Facebook actually has, I think, most of their code, JavaScript code, covered by Flow at this point. So that's millions and millions of production code scaled across a huge code base. So this type system is built to scale code bases and really provide the safety and security that you'd want from a type system. It's developed internally by Facebook, and it's open source through a mirror on GitHub. So what that means effectively is, yes, it's open source, but it's also kind of upstreamed. So you can file issues and do things with it, but it's a little bit insular to Facebook. But the plus side of that is you get millions and millions of dollars worth of engineering effort to build an amazing product that works really well in large code bases. From the functional side, it's written in OCaml. So if you want to look at a live OCaml project, this is probably one that would be fun to dive into the internals. I haven't done that yet, but I might dip my toes in there and see what that looks like. One thing to keep in mind with Flow and with other type systems is that these are compile time checks. What that means is when you're bundling your JavaScript together, all of the types get stripped out of your code and get removed, and runtime, it runs just like normal JavaScript. So you can annotate everything with different syntax, but at the end you just get JavaScript that runs. So this is really nice because you are running code before it gets to your user, and there's no runtime costs associated with running these systems. So why put types in your JavaScript? One of the reasons why I started writing JavaScript and loved it was there was no types. So why is it at this point in my career have I decided, oh, I want types now? Like, that's why I'm using JavaScript. It has no types. Well, it turns out that not having types means you can write code pretty quickly, but it doesn't necessarily scale very well. So you run into issues it actually slows you down in the long term a lot of times, not having types. Your code is less safe, it's harder to use. So the number one thing is scalability, and also maintainability over the long term. If you have code that you want to look at again in a year, or you're actively working on throughout a year or two, or 5 years or 10 years, you want to be able to understand and maintain and work on that throughout time. So it is a really good idea to have types to do that. It serves as live documentation. If a type says it does a thing, it does that thing. That is great. That is a really nice thing to have. And as you onboard new devs onto your team, they can pick up really quickly and know by going into an internal part of the code base that it works a certain way. If you care about code quality and you have a nice solid test suite, this is a great way to assert that your code works a certain way. It is essentially almost like a mathematical proof that your code is correct, and your unit tests can then say, oh, and I also get the output I want. So having a nice type system is really good for making sure your system runs as you expect it to. And if you change your assumptions, you'll get type errors, and you can go and fix those assumptions. So you bake all those assumptions into your types. This makes making code changes very easy. So when you go through and need to, let's say an API changes that you're consuming. Well, you go and change your type for that API, and that will go, and then you'll get errors throughout your code base. And then rather than trying to like grep through your entire code base and find where it happens and find where your logic is wrong, you get a list of errors that you can then work through, which is a much easier mechanical way to make changes to your code base. Like I said, better contracts between APIs and their consumers. So as you change APIs, your consuming code can change. This is one that I really like. When we've been doing a lot of performance profiling of dev tools in Firefox, what we're finding is that Immutable.js, if anyone's used that, has some really bad runtime costs. One of our #1 culprits for speed issues has been Immutable.js, which is runtime checks for immutability. Flow in particular can give you immutable type checks for free with no runtime cost. That's pretty huge. If you don't like the error, undefined is not a function, then types help you there because you know it will be defined. And it puts errors in your compiler not at runtime, so that it won't be surfaced as errors for your user. It'll be surfaced as errors in your console whenever, or in your editor or in your type system before it gets to your end users. So it's much better to fix those first rather than sending them out. So competitors, why Flow? There's other type systems available. TypeScript is the most popular one. It's mostly similar syntax. It's by default it's less strict. It's developed by Microsoft. It has probably, I would consider, a healthier ecosystem around it, more integration with more packages out there, and more users. So for kind of the bigger, broader impact, TypeScript is nice. Flow probably has more strictness, more kind of fancier things that you can do with the types. And if you're using Facebook technologies, it's going to fit in really well. So that's kind of one reason to pick Flow over TypeScript. Closure compiler is actually a type system. Use JS doc tags. It's developed by Google, but I don't personally know anyone using it outside of Google. So you use JS doc to define it, and it provides the types that way. So the first thing to note is on line 1, it says @flow. So this is the first designation that says that you're going to use Flow for the file. So you always need to start with that Flow preamble. So every single file, and I'll reiterate this, but integrate this check into your linting system, because if you forget it, things fail and you don't know why. You're like, why is this not type checking? And you can see I'm just here. I've just enumerated lots of different types. These are kind of the basic things you'd see. A number. You can define things as an object, which is basically almost worthless because just saying it's an object doesn't give you much type safety. Strings, you can define something as null, and notice that null and void are both two different types. Function is, again, another pretty useless, for the most part, type designation, because it just says, hey, this is some function that does something. It doesn't give you much safety, but it has its uses. And then you can actually, on const g here, you can see that you've actually defined an object with certain properties. So this value has to have the property foo, and it has to be equal to the value bar. And then when you're interacting with things like the DOM, you're going to get objects back. So there's a nominal type system, which I'll get into more later, that will give you the names for the things and then provide the methods for them as well. So this would be an HTML element. So those are kind of like the basic units, the atoms of what you're going to be working with. So we already know, start with flow preamble. So what you're going to want to do is add, if you want to use it with a function, here's how it starts to look like for a function signature. Add two numbers, a, and then colon number, all the colon numbers everywhere. But you can see where you specify your arguments and your return types. The return type is this last one here. And you can then add a and b. And if you notice, if you call it, you get no error, but if I uncomment this line, and save it, my editor now has an error in it, which you can't read, but it just says that the type of a string is not compatible with the number. So this is a kind of trivial example of how the types help you not have errors in your code base. I have no idea why debugger is open over here. Other way. So you can actually define a type as a function, and so you see here the type use two numbers, which takes a, which is number, b is a number, and then returns a number. That's a type signature for a function. And then you can define that function using a lambda or an arrow function that does that same work, but you can then define a type independently and do the same thing. Now, one thing that's cool about Flow, if you notice at the top, I do have the Flow preamble there, the Flow declaration. So Flow is going to try to type check this file. But if you notice, I have no types within my file. And what Flow does that's really nice is it tries to get as much coverage by flowing the types throughout your system and seeing how you use them. And here you see I'm going to count do a Fibonacci number, and I'm going to count it, which I tried to do a white theme and kind of messed my tooltips up, but the count is defined as a number in my editor. So it knows that that's a number even though I haven't defined it. So just by adding the Flow declaration to the top, I've got lots more type safety than I did before. I can start to see what types of values are going through my system. And so if I end up calling Fibonacci with a string there, it's going to start to catch errors based off knowing that this is supposed to be a number. Which, it's hard to type with a mic, so I'm going to do it real quick though. So if I change that to calling it with a string, it will actually read through my code and see that I'm trying to here, this says that it's trying to do greater than or equals to 0, which is clearly not a string, and so it's going to give, you don't want to do that operation on a string, so it's going to give me an error. So very quickly I get coverage over a lot of my code by just adding the annotation to check with Flow. So when you're starting to add Flow to your code base, the first time you add that little annotation, a lot of times it'll start to find bugs that you didn't realize you had. You'll have to go and fix those, even if you don't add any type annotations anywhere. So one thing that's really important during code reviews for using Flow types is to check for coverage of your types. And with the screen resolution, you can't see it very well, but count right here has a little squiggly line under it. And that's because I've defined it as an any type. Any types have a little squiggly line, which means you have opted out of any type coverage of it. So Flow will not try to figure out what's going on with it. So if I call Fibonacci here with the string 5, I have no errors on this because it's an any type. You can do whatever you want with it. It's a way to signal to Flow, hey, I don't know what's going on here, just forget about it. So if you're calling into something that you don't have the time to Flow type, or it's third party and it has some things that are wrong and you know the constraints, maybe you have some tests that will fail if you have some invariant that gets violated, and you want to opt out of the type system, the any type is a great way to do that. So it gives you the controls, the safety hatches to get out of it, but you also have to be careful that you're not accidentally using those and not having any coverage. So part of my talk today is we're at a functional programming meetup. So what is functional about Flow? And I will argue that it is the structural typing versus nominal typing that Flow uses that really lets you leverage functional programming. So before I get into structural typing, I'm going to talk about nominal typing. So nominal typing is working with types as a name. So they are a named thing that you can work with. So this is if you're doing OO programming, object-oriented programming, and you're using a class-based system. Nominal typing is really a nice way to work with it. And the browser typically has a mix of functional and OO practices. And so you want to have a nice rich language for dealing with nominal types. So this one is you're going to see some ES6 syntax here, but I'm exporting a class called coordinate, which takes an x and y value as the numbers, so those are the member variables. And I take a constructor which takes two numbers optionally, and then sets the x and y as those values. So this is pretty typical look at how you deal with a coordinate system in object-oriented languages. And then you'd have a method that computes the distance from 0 to that coordinate, and so that's the square root of that math. And you can see that's like a typical method. You can even take an instance of the coordinate as an argument, and you can then compare the two values together. And if you notice, the type for that is just the name of the class. So when it's just the name there, that's the an instance of that coordinate. So creating a new coordinate, if I highlight over this, it'll say coordinate. It's because it knows that it's inferred that that value is a coordinate instance. Which, just one small note, you can pass use the types of the class by passing in a class. Like if you wanted to construct with class here, you do type of coordinate as the argument that you're taking in, and then the return value would be an instance of the coordinate. So just a small little note of how those are used. So this is something that's nominally typed. You have a name for a class. You have all the methods that you go with it. So if you're doing object-oriented programming, this is kind of the core way you think about it. So where flow becomes very nice for functional type of programming is typically you're going to think in terms of structure, not necessarily names. You care more about what the structure of the arguments that flow into your program rather than the names of the things. So here, rather than calling it coordinate, I'm going to call it point. This is just an arbitrary name. And I'm going to define a type of a point that is an object with an x and y value, each of those numbers. And then with that function, rather than having a method, I'm going to have a function. And distance of point, I'm going to give it a point, and it's going to return a number. So the point argument is something that is shaped with an x and y value that has numbers for both of those. So that's a structural way to think about the input arguments, and returns a number. So here's kind of an interesting thing to think about whenever you're creating a point. Numbers can be integers, they could be floats, you could represent them as hex values, you could even do infinity or not a number, and those are all of the type number. And so each of these are valid declarations of points. And here I'm saying that they're points. They have that structure, but you could just leave them as inferred values. So typically in line when I'm declaring stuff, I leave them as inferred values. But at function argument levels, I do them as names. Yeah. So here's using 2 points, returning a number, and finding the max distance of a point. So this is weird. We've got both nominal types and structural types. How do those actually mix together? Well, it turns out they mix pretty nicely for, so what I'm doing here at the top is I'm importing the coordinate, and then I'm importing the point, the type of the point, and also the functions. So those functions are now available in my file. And here I'm creating two coordinates, coordinate A and coordinate B, and point A and point B. And what's nice is my function, when I'm writing it like a function, when I'm using more of a functional programming approach, I can say find the max distance of point. As long as it has a structure that I care about, then it'll be fine. Because I can pass in for max distance of point A and point B, and coordinate A and coordinate B, because those both have the same structure, even though coordinate A is a class that's nominally typed, Flow can look at its structure and pass it into that function. But the same cannot be done for max distance, which is a method, which assumes certain methods that are part of that object. So I'll get an error if I try to give coordinate A and the max distance to that structural item, because that structural object does not have all those methods that is required. Additionally, if you take two things with the exact same structure, two classes that are nominally typed, and try to use one as the other, here this variable test, which is going to be of type foo equals new foo, is fine, but I could not do the same thing with calling it bar. Even though they would be valid JavaScript, in the type system they fail because they failed the nominal checks. They do not have the same name. So I think that's kind of like, if you want one takeaway of like how you start to think about functional programming with type systems, is the structural typing and the nominal typing. So if you're using like React, Redux, and more of the functional approach, typically you'll use nominal typing for dealing with things that already have those opinions, but for your own stuff, you will use very structural types. Okay, let's back up a bit and talk about coercing values. How do you move from one type to the next? So here I have an implicitly defined string called string value, and it equals foobar. If I hover over it, it has type string. But I can do a conversion from a string value to foobar here, because Flow knows that it's a type string, but here you've only set it to this one value. So I know I can set a value to that string literal. I have that safety valve. I can turn off my type system for this value. So I can take string value and then coerce it to any, and then have an any value. So if I have something that's called take number, I can't give it foobar because that's a string, or just a string literal foobar. So if I do take number and give it a string value, it's going to give me an error. So I can't do that. But if I give it the any value, Flow doesn't care. Flow says, okay, sure, you can take that string, and then you have a runtime error, potentially. Or you might do some calculation and you get not a number. That's because you did not have coverage over that type. So again, very important to set the coverage in your editor so you can see it. So here, take number works perfectly fine because I've opted out of flow types. Here I'm trying to take a string value and coerce it into a number. And I'll get an error if I try to do that because Flow says, hey, I'm doing a check. You can't make that conversion. That's not valid. But if I take my any value and coerce it to a number, now I've magically set a value that's a string, so my type system thinks it's a number. So I've basically broken all the rules. So sometimes you need to do this. Sometimes you're dealing with real world values that maybe you're getting it from an API, you don't trust it, you don't really know what the type is, and you need to fix some things. So this gives you the safety hatch to deal with JavaScript types. I feel like this. Okay, let's talk about unions. Unions are a nice way to describe the state of your system. So I'm gonna talk about a state machine here. And when I say state machine, I mean it's just something that has different states and transitions from one state to the next. So I can define some kind of state type as idle, processing, and done. So this is like some kind of typical asynchronous action, which might be hard to handle every single state, every single time. So you can define that as you're going to have these 3 different string literals to, and those are the only possible states it could be in. So writing OO code, maybe even imperative JavaScript, I found I almost never use switches. Like, why would you use a switch? It's verbose, it's hard to write, like I'm just going to do some if checks. I find most of my code uses switches now, especially with unions, because unions end up being very nice way to model handling different states and different cases that go on. So here I'm going to take my state object, which again is idle, processing, or done, and this is a trivial example, but I'm going to call render state, and it's going to return a React element. And here I go over my state and say state is either idle, processing, or done. And I can handle all those cases, and I know those cases are coming through. And then if I get an unknown case, you can throw an error that it's somehow you've done something. The problem is if I go in here and add another case to it, which I'll just call foo, I get no type error. So this is bad, right? Because now I have a runtime error that I've introduced because I haven't handled this case. But luckily, Flow gives you some tools to handle this. There's a special type called empty. So before, if I undo this and then save, if you can see the state right down here has a squiggly line under it. It says it's uncovered by Flow because it's like, well, what is this thing? There should be nothing here. It should be empty. While if I re-add that type and then go back down and hover over it, did I save? It'll say it's a string. So now Flow knows that there's still a value here. So if you add a simple type annotation, then it'll catch that error, which I'll do right now. So the empty type means there should be nothing here. And now I get an error. Let me run it. Here it's unknown state, string literal foo, this type is incompatible with empty. So I know I have unhandled cases. So if you think about this, if you think about like you have some state management and you have certain cases that it handles, or like a context menu that does certain actions, you can change one type definition and then your entire program will light up with errors where you know you need to go fix it. This is huge. This saves so much time in being able to go through the application and make changes. If I want to add something to a context menu and I know I need to handle it everywhere, you change the type definition, my code base lights up with errors, I one by one mechanically go and fix them, and then I save it and run it, and my code more often than not runs the first time through with no runtime errors, which is really a magical feeling. Now before, those are just simple strings, but you probably want data associated with your states. So now this is going to start looking a lot more like, if you've worked with Redux, how you deal with actions or things like that. You can create an object, which is a union of different types of objects, and give a type value, which would be idle, processing, or done, and include data with it. So now processing, let's assume like as it's processing it, it has some percentage that it's done. And so that object updates as it gets done, and then when it's done, it has some message about the work it's done. So here I can write a function that will then take those values and then go through them and let me use that data. And the colors are horrible here, but you can see when I hover over my state, Flow has refined that type to just the one value that I care about. So I can see exactly what values are there. So this is, my state is the type processing with the percentage value. So I know that's the only place I can access that percentage. If I tried to access the percentage on any of the other case branches, those would not be there. So this is like a really nice tool as you're writing Redux or React code or any type of functional code to handle different cases in a very functional way. Yeah?
On the cases, if you leave off a default case and add an option, will it complain that you haven't handled all of your cases?
It only complains, so by default,
So if you go back to one before that, and if we add the food to the list up there at the top.
yeah. My muscle memory is completely destroyed by holding a mic.
Will it complain if we remove default that it hasn't handled a particular case?
So here, there's two things. There's what I do is I configure my ESLint to always require default case. So that way ESLint won't complain. And the second thing I do is always add the empty type. If you don't do those things, then no, it will not complain. So there's one that you can configure with ESLint to always have default, but then if you leave it so that you don't check for an empty state at the end, you can run into errors. So potentially, yes, you'll run into issues with it. I'm not sure of an ESLint rule. There might be one that would check for that case, which would be handy. So has anyone used immutable.js? So immutable.js gives you objects that you cannot change and gives you a whole bunch of functions for working with them. So it's a nice way when you're first really working with immutable data to ensure that you're doing it correctly. The problem is it has lots of runtime costs. So luckily Flow has a way to deal with talking about mutability and immutability. So mutable objects are ones that can change. Immutable ones are ones that will not change. So here you can see the two different type definitions. The second one has little pluses in front of the properties. So those make those properties cannot change. So let's look at this single point in space. I've created two of them, a mutable point and an immutable point. So here I have a function scale mutably, which takes that point and does times equals the value. And then a second point, which returns a new value without changing the original. So scale mutably, if I pass in mutable point and 2, it works. If I pass in the immutable point, I'll get an error there because I'm trying to change a value that can't be changed. So here you can see the error. This type is incompatible with this type is incompatible. I can't scroll left, right. Oh well. Anyway, there's an error. Hopefully it's readable. But this gives you a really nice tool to be able to work immutably with your type system with no runtime checks that you have to worry about. So it makes your JavaScript experience more rich that way. It gives you more tools you can work with.
The plus sign is how you do it with Flow, right?
Yes, with Flow.
Cool.
There's also another way where you can there's a utility type, which I'll jump ahead, called read-only. So you can also do it with a utility type, which I'll get into those. I tend to prefer the pluses. Okay, let's talk about inexact objects. So when you define a type that's an object, you're just saying this object has this structure. It can have other structure with there, and it'll just ignore it. It only cares about the things you've defined. So these are inexact objects, and I'll show kind of some of the caveats that come with that. And this would be the default way that you deal with the types initially, and so I'll have a recommendation to use exact types, and you'll see why. So here I've created types of point 2D, point 3D, and I've instantiated two. But they are inferred types, so I'm not actually explicitly saying the type of it. And I have two different functions, getLength 2D and getLength 3D. And I'm doing something fancy where I'm destructuring the values out right away, which I find I do a lot with structural programming. And here you can see I can do getLength 2D with a point 2D and getLength 3D with a point 3D. Yay, everything works as we expect. So what happens if we start making errors here? Well, let's say dimensions don't match for the getLength 2D and you give it a 3D point. Well, that's still a valid thing to write because it still has 2 dimensions in there, but it's perhaps not the thing you want. Flow will not complain because a 3D point has the X and Y properties, so it matches that structure. While if I try to getLength 3D off a point 2D, the 2D point will not have that Z parameter, Z property, and so it will fail. So the way you do that is you can add these little bars to the object, and that signifies that it's an exact object. And this will make that error actually happen now. So now dimensions do not match, trying to get a length 2D with 3D because the Z property will exist where it's not supposed to. So I tend to opt for as precise of a definition as I can. So everywhere I create objects, so if I'm defining my my Redux actions, I define them as exact objects. I define them as read-only, immutable objects. Try to be as strict as possible. It makes the type definitions a little hard to type and a little verbose, but it will catch more errors. And you can always lift those restrictions back if it turns out you actually do need to be less precise. Especially with the utility types, you can transform your types. So let's look at another way to define a 3D point. The 3D point is made up of whatever's in the 2D point. So here I've defined a type, with this x and y for point 2D, which is what you've seen before, and then point 3D, which does the rest, which is the dot, dot, dot. So if you use ES6, that should look familiar. It spreads those in there and then has the z parameter as well. Now the trick is you need to use exact types whenever you use this, the rest syntax. The reason why is you could be saying fill in these two properties and whatever else is in that object, which we don't know what it is. So it changes, there's a different meaning for it. So just one thing to keep in mind. So again, being more strict with your types is better. And then I can create the 3D object with the x, y, and z, and it's correct. So who here uses React Redux? Anyone? One? So React Redux does this thing where you combine properties together to create a new properties object. So your React element takes the props which describe how to render it. And if you want to combine different props together into one object, you need to be able to a way to describe that with types. So here's how I would do that. So I would have the properties own props, the state props, and dispatch props, and define them all separately. And then my final props would be using the rest syntax to put all those in there so that you can have one object with every single object combined. So all those properties will be combined into one object, and that final object will be composed of everything that's in there. So this would be the same thing as doing object.assign in JavaScript. But this is only the type system that you're doing that in. So this is beyond kind of the scope of this talk. But one thing that's really nice about Flow are the utility types. They give you an expressive way to really go through your types and manipulate them in very functional manners. So you can get the keys of an object. So if you want to get like a list of all the properties in your props or whatever object, you can get the keys. You can get the values. You can transform an object to be read-only. You can turn it from an inexact object to an exact object. You can diff the properties from one object to the next. That rest operation you can do as well. You can get the property, the type of some property on an object. But this gives you a way that a lot of times functions will take an object and then manipulate and get some value out of it. And this gives you the type system to describe those operations. And so the type signature of the function becomes really quite useful. And you can use it throughout your application to change the values of the different objects. Object map runs a type through a function, so it actually maps it, which is kind of mind-boggling. You can manipulate types really, really well with that. Tuple map does it with a list of tuples, call, class, supertype, subtype. Okay. So that's kind of an overview of some. I left off dealing with generics and templates with Flow, so you can do some neat stuff with that. And it's better if you don't have to deal with some of the complexity of the type system because it makes your code harder to understand, more verbose. But sometimes some part of your application really needs it. I wrote my own definition for the React Redux library because I found the existing one not sufficient, and it's a pretty complex set of types that really uses all these like utility types. So if you can avoid using them, a lot of times it's better to keep it simple and just kind of not bother with getting your types absolutely correct. But if you're finding you're getting bugs and you need to fix those bugs, and those bugs are going to be your users, sometimes that complexity is warranted. So top tips. Integrate it into your continuous integration and make it fail, and not so you can't merge in PRs if it's not working. Make it as strict as possible. This saves you so much heartache, and it can be difficult at times getting things to pass for the first time, but it pays off. I like to write the documentation in line with my types. So I add a comment block above my types listing crazy documentation. In fact, I want to show one real quick. So whoops. Here you can see, here are some type definitions in my actual project which have really long comment blocks with ASCII art for something that's like a really simple definition. But it's explaining what those parts are going through. So if I go in my code base and I see some random focus subtree type, and I'm trying to figure out what's going on with it, I can dive through my editor, just jump to that definition and see everything about it and read about it. So it serves as a really nice way to document things.
Did you space that ASCII art yourself? Or?
Oh yeah. I love ASCII art. It's some of my favorite stuff. I write a lot of ASCII art. ASCII art is nice. Sometimes I'll do it on paper first. But translating that to ASCII art, it takes a little bit of effort, but then it's in your version control. It's diffable. Like, it has all these really nice properties. I really like ASCII art. I should do a talk on ASCII art. I write my tests using ASCII art, like as the assertion. The assertion is the ASCII art. Integrate coverage reports into your editor. The worst thing is thinking you have flow coverage and you don't. If you don't have integration in your editor, if it's not visible, it's really bad. So most editors have integrations that I've looked at, and you can Google them for your own specific one. Another really important one is set up ESLint to fail if no flow declaration. It's really easy to like go through a ton of effort, write your types, oh hey, they all work, and realize you forgot the flow declaration. And it's just because everything's an ini, and it's not doing anything. Be strict and correct only where needed. Sometimes it is possible to type something, but it's so complicated that it's not worth the effort to write it and maintain it. I would say default to typing, but don't feel bad if you can't or shouldn't. For instance, I don't know if I have it on there, but it can be difficult to mutate objects and describe that as a type. A type with lots of intermediate states can be difficult. So have a type definition at the start and the end of the function, and inside the function, do whatever you need to do, coerce to any, and then write a good unit test at the end. I would say shoot for greater than 95% coverage for each file. Again, exceptions apply. But I found whenever you have that much coverage, as long as you're looking at it, it's pretty easy to do and get done. Exact object by default, immutable properties by default, and also, pro tip, ignore your node modules directory and rely on library definitions. Because otherwise, Flow will be trying to chew on all your node modules, which if you like battery life, don't do that. Perhaps it provides utility, but I don't like that. And difficulties, which I shouldn't leave on a low note, but I guess I will. React Redux is really hard to type. Chat with me afterwards if you want to see what my type definition looks like. It's pretty gnarly, but it works. Higher order components. That's like the recommended way, rather than doing mix-ins for creating components that need to abstract some type of work. Those are very hard to type. It's doable. So those end up being quite difficult to get correct. Which, if you just kind of write them naively using all the built-in definitions, typically they'll pass, but they won't provide you type safety. Again, complex object mutations are hard to do, which I just coerce to any and then abstract it in a function. Lack of library definitions. There's flow typed, which is a library which you can import definitions, but TypeScript has a beat like crazy on how many there are. So if you have a code base with a set of dependencies that you're okay supporting yourself, this is a good fit. If you are writing lots of code and using lots of arbitrary libraries, TypeScript might be a better fit. You have no runtime verification of types. If you're consuming from an API, make it loose and then do checks yourself to verify that the object is actually shaped like you want. Because if you have wrong assumptions, your code's going to behave incorrectly. Then the last kind of difficulty is it's an open source project, but it's internal to Facebook, and so they're not as responsive to the community. So don't expect lots of hand-holding from the actual maintainers or even upstreaming patches. They do eventually get to stuff, and it's very actively maintained, just not as responsive to contributions. But yeah, that's my talk. Any questions? Cool, thanks so much, and feel free to hit me up, and I'll show you some of my gnarly types that I have in my project. So thank you all.